Let's look at the unit circle that's used in trigonometry. Now, when it comes to trigonometry, the trig identities, trigonometric identities, understand that sometimes there are so-called circular identities, right? The trig ratios, they are really circular ratios because the sine, cosine, and tangent are based on the unit circle. Now, yes, this is a circle, but why is it called unit? Well, they call it unit circle because the radius is equal to 1 unit. Alright? That's the radius. Just 1 unit. That's it. So, therefore, they call it the unit circle. Here, let me just do a little thing here. Here, what we have, for example, when we talk about the sine of an angle, you remember you have a triangle and in this triangle you have an angle here, call it theta, Greek letter theta, right? Could be any other letter. This angle is on the left and this side is on the right, so this is on the opposite side. This is the right angle right here. And this side runs alongside the right angle, so it is called the adjacent side. Now this side up here is adjacent to it too, you know. But you keep the name of this side that's opposite to the right angle, it's far away from the right angle, as a hypotenuse. Alright? Now the sine, SINE, usually called SIN theta, usually written shortened form. Sine theta is opposite divided by the hypotenuse. No matter how big or small the triangle is, as long as you draw it accurately, opposite divided by the hypotenuse will always give you the same number. Alright? So, if you have an angle, first of all, remember, angles are measured in an anti-clockwise direction, and this is considered 0 degrees. Right? Now the thing is, if this is 0 degrees, and you come right around here, that would be 90 degrees. And you continue here, that angle would be what? From 0 go all the way around here would be 180 degrees, and then all the way right here would be 270 degrees. Let me just write the degree sign, and then from here coming all the way right back would be 360 degrees. All right? So now, if you have this angle, say this is alpha, angle alpha, all right? Now, the thing is, you say sine of angle alpha equals what? This is the opposite to alpha, and this is the hypotenuse. It's going to be some number, the length of the opposite over the length of the hypotenuse. That is what is going to be equal to. But you are going to see that there's another angle that will give you the same value if you find the sine of that angle. If I should reflect this angle over here, this is also the hypotenuse. The hypotenuse is the same as the radius of the circle. You can see that. But the opposite is now here. You see that? Now this is going to be the same as alpha. So it's just that you're reflecting this right angle triangle over here. There's a reflection over the y-axis. But guess what? Remember, you measure angle from here in an anti-clockwise direction. So there's a new angle that we're looking at. The angle is this. Alright? Now, what is that angle? The thing is, if you go all the way here to 180, then you go back the same as alpha. This angle will be 180 minus alpha. So guess what now? When you consider it, the sine of alpha is going to be equal to the sine of 180 minus alpha. I want to try it with some numbers. Let us see. Let's take this unit circle. I want to make a copy of it and put that copy down here and try it out. Suppose this angle here is, say, alright, call this 30 degrees, alright? That's 30 degrees. You have the opposite and you have the hypotenuse. Sine 30 is opposite to hypotenuse. Now, if we use our calculator and find the sine of 30 degrees, you say, this calculator behaving like this. Okay, sine 30 equals, see that? It is a half, right? It means that this opposite is going to be half of this hypotenuse. But now, suppose we draw a similar right angle triangle over here. The right angle here, right angle here. You see, this is 30, you know. But you're not going to use that angle. Guess what? You start from here and go all the way right here. So the angle that we're looking at is this one. What is that angle? What that is going to be 180 degrees minus 30 degrees, because we imagine coming all the way to 180, then we go back around 130 degrees. So here now, 180 minus 30 is what? 150 degrees. So the sine of 30 should be the same as sine 180 minus 30, which is sine 150 degrees. All of these are degrees. Is that going to work out? Let us see. If the sine of 150 degrees also gives us a half. So sine 150, no for it, equal, you see, it is a half. So sine 30 equal sine 150 equals half. Both of them are equal to a half. You see that? So far, we found two angles such that when we find the sine of those angles, we get the same value. All right? Now, suppose you were given an angle. You don't know the angle. Sine theta is equal to a half. And you're asked to find theta for theta being greater than or equal to 0 degrees, less than or equal to 360 degrees. That means it's somewhere between 0 and 360 degrees. We would have found two angles already, 30 and 150. So that sine 30 gives half, sine 150 gives the same half. Or you might say, suppose you do this. That, you know, is the same triangle. Same as this and this. It's just that you draw it down here. Is it going to give you the same value? Remember, this is 30, 30 degrees. But our angles, positive angles, are measured from 0 in an anti-clockwise direction. So to find that angle, we have to go all the way around and stop here. What would that angle be? Well, you pass 180. So the angle is 180 plus 30 more, which is 210 degrees. Now, let us find the sine of 210 degrees and see what it would give us. Is it going to give us the same half or something else? Because guess what? It's the same triangle. Let us see what is going to happen. Calculator. Now, we want to find the sine of 210. That is equal to, it's a negative 0.5. It says that the sine of 210 is negative a half. So how is it that the sine of 30 is positive a half and that one is negative a half? How is it that the sine of 150 is positive a half and for 210 is negative a half? Let us see what could be happening here. The opposite, this is the opposite for 30 degrees. This is the opposite for 150 degrees. This is the opposite for 210. Oh, you notice something? When we find it, draw the opposite and measure it. It goes from 0 upwards in the positive direction. Positive hypotenuse, positive opposite over the hypotenuse. The hypotenuse is always positive. It's the radius of a circle. So the opposite is positive over the positive hypotenuse. Gives you a positive half. Let's see what happens over here. The opposite is measured from 0 upwards. That's the positive direction of y. So it is positive. A positive opposite over a positive hypotenuse gives us a positive half. Positive value. Alright. Now here for 210, the angle goes downwards. It is in the negative direction of y. So it's a negative opposite over a positive hypotenuse gives you a negative value. That's negative a half. And you say it might be interesting if we now do this. Suppose we draw another triangle. This is 30 degrees, so you know. But the angle we're looking at here goes from 0 in an anti-clockwise direction, so it goes all the way around here, right? So our angle here swings all the way around to here. Now what is that angle? This angle here would be 360 minus 30. See that? If you go all the way to 360, then you back off 30. This is what you get, which is 330 degrees. Now, before we find the sine of 330 degrees, let's think about what it could possibly be. Now, this opposite here, right, is the same length as this opposite here. Same length as this opposite, same length as this opposite. And the hypotenuse is the same. It's the same radius for the same circle. So you expect to get the same number, which is half. But is it going to be positive or negative? Let's see. The opposite for the 330 degrees, measured from 0 downwards. So I expect that the sine of 330 is going to be a negative half. Let us see. Want to find the sine of 330. Sine 330 degrees equal negative a half, right? So what we have here is that the sine of 330 degrees is equal to negative half. So between 0 and 360, we found 4 angles. 2 of them, the sine of that angle give you positive a half. The other 2, they give you negative a half. So if we should find out which angles, when you find the sine of that angle, you get positive a half, there will be only 2. Alright? So there we have it. Now, let's just label these parts of the circle. This circle, unit circle, is divided into 4 parts. Let's copy this unit circle, put this down here, and talk about this. Now, you have 360 degrees, and it's cut into 4 equal parts, divided into 4 equal parts. That 360 degrees divided by 4 is 90. So you see this part as from 0 to 90 degrees, 0 degree to 90 degrees, then 180 degrees, and 270 degrees, and back here is 360 degrees, one complete revolution, right? You go all the way around. I'll stop back here. Now the thing is, when you have anything divided into 4 equal parts, you can call each part a quadrant. Quad meaning 4, alright? So this is considered the first quadrant. It's quadrant, but I just shorten it. Use the space. First quadrant. 90 to 180 contains the second quadrant. 180 to 270 contains the third quadrant. Let me rewrite that. Third And between 270 and 360, you have the fourth quadrant. So you have four quadrants here. First quadrant is 0 to 90, second quadrant 90 to 180, third quadrant is 180 to 270 degrees, and fourth quadrant 270 to 360 degrees. So the angles, as we saw a while ago, the angles whose sines are half are located in the first quadrant and the second quadrant. Right? In general, you see that where you find two angles between 0 and 360 will give you the same sine, they will be located in the first and the second quadrant, because the opposite in both cases is positive. Alright, so any questions, you put it in the comment section. If you're not a subscriber, please subscribe to the channel and share the video with somebody else. I will see you in the next video.